Hello guys, welcome to my YouTube channel again. In this video I'm going to show us on how to attempt question under electrostatics using Coulomb's law. This question was adapted from past question Obafemi Awolowo University 2008-2009 rain semester number 26. So if you want to check it out, please you can check it out in the year 2008-2009 rain semester exam number 26. The question says, in vacuum, two particles have charges of Q1 and Q2, where Q1 equals to minus 3.5 microcoulomb. They are separated by a distance of 26 centimeters, and particle 1 experiences an attractive force of 3.4 Newton. What is Q2 in magnitude and sign? The question is asking us to find the charge Q2, the magnitude and the sign of the charge. If you guys remember, in the previous video I explained the types of charges that we have. We have two types. There can only be two types, and that is positive charge and negative charge. There is two chances of what charge this would be. It can either be positive or it can either be negative. So they ask us to find out the charge, the magnitude of the charge, and the sign. Is it positive sign or negative sign? What this question is trying to tell us that in vacuum, they are trying to explain to us that there is no other charge affecting it other than Q1. No other charge. It is just Q1 and Q2. And the value of Q1 was given as, let us write the value of Q1 to be equals to minus 3.5 microcoulomb, which is equivalent to minus 3.5 times 10 raised to the minus 6 coulomb. Q2, which is not given, we'll have a question mark. We want to find the magnitude of Q2 and the sign of Q2. Thus, as the magnitude of Q1 is 3.5 and the sign is negative, what is magnitude of Q2 and the sign? Would it be positive? Would it be negative? Okay, let's find out. These two charges, they interact with each other, and the force of interaction between each other, F on 2 due to 1, since the charge in question is charge 2. So I am going to make sure that the force acting on 2 due to 1 is the one I want to calculate it for, which is equals to, they already given us that the force acting on 1, it is already stated, due to 2 is equals to 3.4 Newton. And the distance between them, R, is equals to 26 centimeters, which is the same thing as 26 times 10 raised to the minus 2 meter. Using Coulomb's law, it is known that the force of attraction or repulsion is equals to K Q1 Q2 over R square. Since I am taking the magnitude of Q1 and the magnitude of Q2, so this is going to be the formula. This slash between Q1 and the slash that borders Q2, it represents the magnitude of Q1 and Q2. That is, if you want to input our data in, you are going to neglect any negative sign or any positive sign. We are just going to put the magnitude in it. The force is given as 3.4 Newton. That is equals to, remember that our K is given as 9.0 times 10 raised to power 9 Newton meter square per coulomb square. It is constant. K is constant. So I'm going to write 9.0 times 10 raised to power 9 Newton meter square per coulomb square. 3.5 times 10 raised to power minus 6 coulomb. And the magnitude of Q2, which I'm about to find. Over distance between Q1 and Q2 is given as 26 centimeter. 26 times 10 raised to power minus 2 centi. It implies minus 2. Please remember to always put your square on top of the distance. Since I'm going to find for Q2, so I will say 3.4 Newton times 2.6 times 10 raised to power minus 1 meter square. I only convert this to standard form. 2.6 times 10 raised to power 1 minus 2 plus 1. This is converted to standard form. Over 9.0 times 10 raised to power 9 Newton meter square per coulomb square. Three 3.5 times 10 raised to power minus 6 coulomb. And that is equals to the charge, magnitude of charge Q2. We are finding the magnitude of charge Q2. If you punch your calculator, you are going to obtain if you punch your calculator, the value of Q2 that you will obtain here would be Q2 to be equals to 7.3 times 10 raised to power minus 6 coulombs, which is the same thing as 7.3 microcoulomb. That's the magnitude of Q2. Now, how do I find the charge? Whether there will be positive sign here or it will be negative sign. Let's go back to the question. Two particles have charges of Q1 and Q2, where Q1 is minus 3.5. Please note this sign of Q1 is minus 3.5, minus, right? Negative. They are separated by a distance of 26 centimeter, and particle 1 experiences an attractive force. Thank you. The point that I need to information I need to point out from the question is attractive force and the negative sign here. If you recall, I said recall. Like charges towards repair. Unlike charges would attract. Now, if there is an attractive force, it only implies that Q1 and Q2 are unlike charges. Given that we know the charge, the sign of Q1, we can already deduce that the sign of Q2 is opposite to the sign of Q1 because they are unlike charges and they attract. The question say experience an attractive force. Had it been it is otherwise, that it is stated that it is a repulsive force, they will be like charges and the charge will be the same thing, but that's not the case here. The question says the particle 1 experience an attractive force. The force of attraction is felt between them, and so thus, I would say, since the force experienced between the charges is an attractive force, it implies that the charges are unlike charges, that is opposite charges. Thus, if Q1 is negative, Q2 must have been positive. Finally, I'm going to conclude that magnitude of Q2 is 7.3 microcoulomb and it is a negative charge. That is, it is a positive charge, positive charge plus 7.3 microcoulomb. If you check the question out in the past question, please practice more questions regarding electrostatic, and I will see you guys in the next video. If you think this video is useful, please click on the subscribe button and turn on the notification for more videos so that you can get the notification, and please like and share. If there is anything you need to comment on, please comment down below. Thank you.